start this. This is going. There, it's going now. So, what are we doing? We have homework for today. Was there anything that caused particular grief? By the way, just so you know, I took the homework and I moved it back so that it's not due till tomorrow. I only did that just before class, but it was only so that we wouldn't get that screen, the one that says we're all, like it turns it off. It says you're out of time. So that way, if we do need to discuss it for longer than 15 minutes, we're good. So, was there anything that we need to discuss from this? Yeah, Jackson? Down here, the total area. Yes. Okay, this is a good example because it's similar to the quiz. Is it similar to the quiz? Close enough. Um, and so this might be good for us to do. Let me copy it, and then I'll put my iPad up on the screen. So I have the function y is equal to 0.5x to the negative 1.5. You probably have something similar. And we're doing the integral from 5 to infinity. Okay, so this might be a minor uh, issue is that if you had trouble with the total area, what they were talking about there is they want to know the whole area from 5 off to infinity. So the entire area under this curve. Um, so it might have been just the words that were a problem. So like Jackson said that he was fine with this and this. So I'm going to assume that those are correct. And then the total area. Let's go ahead and do this calculation on the iPad. So we're doing this 0.5x to the negative 1.5. And so this is going to equal negative, oh, I should write it. And Lumen doesn't know and doesn't care if you write things correctly, but I do. So I'm going to ask you to try, please, to at least humor me on this point and write it like this, the limit as b approaches infinity. At least make a nod to the fact that this is a limit, because if you don't, I will mark it wrong on the test. I won't take off full credit because I know you know how to do this. It's just a notation. So please, at least put that down there. Like I said, Lumen doesn't care. They don't even know what you're writing down on your paper. But this is what we're actually doing. We're doing a limit. And so for all of the improper integrals, you should have a limit, including the one I have on your quiz today, should be a limit. You'll get this in a minute. As with all quizzes before a test, I don't collect it, so don't fret. It's going to be okay. But anyway, getting back to this, this is going to be this, 0.5x to the negative 1.5. Sorry. By the way, on the practice test, the answers that I actually uploaded this morning at like 7 o'clock, you'll see that I actually use a limit. I use this notation for all of my improper integrals that are on there. Are there improper integrals on there? I hope so. But anyway, let's go ahead and do this now. So we have the limit as b approaches infinity. I'm guessing that this part wasn't a problem because you got parts A and B correctly. Done. So this will be negative x to the negative 0.5, I believe. Evaluate x equals 5 to x equals b. Because if you got parts A and B right, you know how to do the antiderivative. It's negative because you're dividing by negative. You add 1 to this power and then divide by this. That cancels and you get the negative there. That's not a big deal. And this becomes limit as b approaches infinity of negative b to the negative 0.5 minus negative 5 to the negative 0.5. Let me write down what this actually means. B approaches infinity. Sorry. This is negative 1 over the square root of b. That's what b to the negative 1.5 means. And this will be plus 1 over the square root of 5, the double negative there. Now you just have to ask yourself, what does this limit equal? So the limit as b approaches infinity of this thing is going to be 0, because if you put a big number in the denominator of a fraction, it ends up making the fraction really, really small. And if you let that number be so big that it is infinity, it grows without bound, then this fraction will shrink without bound to 0. So this will be 0 plus 1 over radical 5. 1 over radical 5 would be my answer. I don't know if that's going to, so it may be that they wanted that. Let me just see what they wanted here. Whoops. There. Oh, they have a, that's so weak. I would have thought that, let me see, can I type in 1 over the square root? Whoops. Of 5. Will it like me if I do that? Yeah, it did like me, at least with that part. Okay, good. So, but apparently they don't mind if you do a decimal. So you could have, just so you know, you could have done what they suggest up here. They say try going to t equals 10, try going to t equals 100. You could have done this for t equals 1 billion. And I'm guessing that if you did t equals 1 billion, you would get a number close enough to this that Lumen would be happy. However, let's do it right. And, 1 over radical 5 is so much nicer than that. I mean, just look at this. Look. I hope you can see that aesthetically, the one on the left is way better. I know you engineers, you love decimals, but the one on the left looks nicer, doesn't it? Whew. Okay, anything else that we need to deal with? Sorry, it just got a little hot there. We're okay? Wow, this wasn't too bad of a homework. I mean, you just basically, and let me just tell you, I mean, I want you to feel okay about yourself. And that is to say that if instead of writing all of this down, if instead you did this, let me just do this real quick. Let's see, sorry. Let's see, this is negative x to the negative 0.5 from 5 to infinity. There we go. Okay. So I'll put this in a little thought bubble. There. So you can't see. That's all right. Now you can see. So if instead of doing this over here, you did this over here, notice the difference in notation, left and right here. There's the correct way. That's the incorrect way. This is the way I generally do it, even though this is correct. So if you did do it this way, you're not entirely wrong. It's just that notationally you're wrong. So humor me on this quiz, or the quiz and on the test, and put the limit in there. We can work on this if need be. Let's give it a go, though. I was passing out the quiz to my first class, and some of them got this quiz instead of they're doing derivatives still. And they were like, what? What's that symbol? They got all scared. No, I made a mistake. But it was kind of funny. You didn't get enough? You didn't get enough? I thought for sure, even for you? It's amazing. I thought that I gave you such a huge stack. Wow, you have 2 bit. Oh no, they're connected. Did you sew those things? Okay. All right, everyone got one now? Excellent. Good. Let's see if I can figure out myself. I'll put it up on the screen for anyone who's watching from home. Beautiful. So I'll give you like 5 minutes to do this, and then we'll go over it as a group. So I'm not going to collect this, but still try to do your best and put a limit in there somewhere. So, humor me on that point if you would. You're all done? Oh, I don't know if you were waving. Okay, you're okay. I just caught the look at it. You carry on. Was this too easy? Maybe this is too easy. Some of you seem to be done. We're going to go ahead and give this one a go, and see how I was hoping you'd do this. I know I just copied a bunch of stuff here. So the first thing is to replace this upper limit with the letter B. So if you do this on the test, at the very least, write this down. Even if you're thinking to yourself, I don't need to do this because I know it's a limit. But, put it down. It's a limit. There it is. That's what infinity means. And then that is going to equal the limit as b approaches infinity. Let's see if I can get rid of all of this stuff. And that stuff too. The antiderivative is going to be this, is it not? How's that? X equals 0 to b. Did I get my antiderivative right? You can always do u substitution. U equals x plus 1. Du is equal to dx. So 1 over u squared is the same as u to the negative first power, or negative second. The antiderivative is negative u to the negative 1, which is this here. So yeah, get your antiderivative correct. Very nice. Now I'm going to just do this. I think I'm done copying my ink there. So this is going to be negative 1 over b plus 1 minus negative 1 over 1. And then you can just say that that's 1, and I'll be happy. In fact, if you want to be really minimalist about this, I don't know, you probably could cut corners even more than this. But this is I've done pretty I've cut quite a few corners already. But yeah, the reason why this is 1 is because as this increases without bound, this fraction will decrease to 0, which leaves you just with that fraction, negative, negative makes that positive. So that wasn't too bad, was it? This is pretty easy, especially after all the pain and suffering that we went through with partial fractions and trig substitution. I put your test together yesterday. I'll show it to you today. Anyway, the test, I was like, every time I came across a problem that I basically took the practice problems and I was like, do I want this on the test? No. Do I want this on the test? No. Do I want this on the test? Well, maybe if I make it easier. So that's what I did. We'll talk about this in a minute. Let's take a look at the practice test though. So I have this here. I uploaded the answers. Rather, I uploaded the alleged answers. As always, I do this stuff while I'm playing video games or while I'm being distracted by something, while I'm riding my bicycle. I'm doing something else usually when I'm writing up my answers to this stuff. And so if I make a mistake, cut me a little bit of slack and just, let me know about it and I'll correct it or whatever. So but the alleged answers are already online to this. But before we take a look at those alleged answers, here's what I mean by the actual test being easier than this. Well, for one, I don't have duplicates like here. Isn't that one the same as this one? So I was like, I think what I did was I just gathered together some old exams of like, let's grab that stuff and this stuff and put it all together. So that's why you have some duplicates, I guess. But here we go. Case in point, just taking a look at this, it's not that hard. But on the actual test, I was like, I'm just going to keep the numbers as small as possible. And so on the actual test, I might have something like this, cosine squared. Nice and easy. Or something like this, the integral of sine of x times cosine squared. How about that one? That one's not bad either. So I kept things as basic as possible on the actual test. So if there were complications that arose with the practice test, I really tried to avoid them, especially after having actually done the practice test pretty recently. I was like, oh, this is no good. I can't have that on the actual test. So with that said, let's take a look at the practice test first. I can pull up the answers if you need me to. So if you've already looked at the answers and you're like, you're wrong, I'm fine with figuring that one out for you. And then we'll take a look at the actual test and compare. Although I won't show you, you know how I like to do it. Let's do this first. So practice problems, anything that we need to go over that you're thinking this stuff is terrible. Yeah, what do you think, Cooper? Oh yeah, good point. Yeah, so Simpson's rule. Simpson's rule was me thinking that we would get further than we actually did. So that is not part of our actual test. Sorry about that. Yeah, that we'll be doing that after the break. You can look forward to it. Simpson's rule is a way of just, if you're really curious, it is a way of computing integrals numerically. So you know how your calculator, you have the Math 9 button? Math 9, your calculator does not know the antiderivative of cosine is sine. I'm just telling you, it does not. But what it does know is it knows Simpson's rule. And so when you do Math 9 and you have it do the integral of the sine, or the cosine rather, it's actually applying Simpson's rule, which we'll go over after break, to get a quantity, a numerical number. It doesn't give you a symbolic answer. It just gives you. So some calculators, if you have the TI Inspire, it'll do a symbolic processing, and then it does know that the antiderivative of cosine is sine, but most calculators don't know. All right, so thank you for reminding me I needed to mention that. Yeah, that's not on your test. Don't fret. What else do we need to take a look at before we take a look at the actual test? Maybe you really want to see the actual test. Yeah, what do you think, Rachel? Mm-hmm. That one's fun, isn't it? Okay, just a minute. Before we take a look at this, um, let me double check. I will get the actual test up here, and then we will compare. Give me a sec here. Close, close. I've got so many things open. I've got all these exams that are being on Friday. What was I thinking? Okay, give me a sec. Where is it? Exam for Calc 2? Is that the one we want to look at? Sure. Okay, exam for Calc 2. So on the exam for Calc 2, I have two integration by parts problems. So I'll just be completely forthright with you that neither of them is quite like this one. So with that said, we could still go over that one if you really want to, or you can save it for your own enjoyment. Where is it? It's here somewhere. There it is. So here's my no. Oh, it doesn't. Does it say? It doesn't. But this one, this is entitled "Practice Problems with Alleged Answers." So let's see. Where is it? Oh, there it is. So here's my work. Basically, what you end up doing is you end up doing integration by parts twice. So there's the first one is in red, and then I get this thing right here. Oh, it's up there in red. And then I had to do it in green, and then I got this stuff in green, and it's a mess, but I ended up basically solving for the the integral that I was interested in, and I got this as my answer. So it is possible to do that one, but it involves some algebra at the end, and you do integration by parts twice. What is probably more pertinent for you to make sure that you know how to do is something like letter B, or like like this one. Yeah, the two that I selected are like those three. So those are not to say that you shouldn't care about that one, but you can, at your leisure, when you're done studying for the other three, you can take a look at this one and say, oh, that's how it works. It's not that hard. It just means you have to. It's a little involved, and so I thought that's going to take a little bit of extra time, and I wanted to make sure that you can get to Tavares Taylor. That's my goal. So I didn't put that one on the actual test. So what else do we need to look at? Let me just go back to the practice test. There, the blank one. There's the blank one. Yeah, what do you say, Luke? Uh-oh, wait a minute. Question B on 4, you got a different answer? So tell me, did you use integration by parts 3 times, or did you do the table? You did the table? Okay, let's see. Okay, so let's just go back here to my alleged answers, because I might have been distracted by the video game that I was playing. Probably that's the case. But actually, I gave up most of my video games for Lent, and so I'm stuck. That's why I'm just stuck with what is it called? Crossy Road Cross. Anyway, yeah. So it's kind of hard to do that, and you can split screen this. Here, let's see. So I can, I don't know. So you could have the Crossy Road on one side and this on the other. Yeah, I see now. I think, no, wait. No, I'm good. I got it right. So first things first, let's see how we did this. The way I did this, now you could do integration by parts 3 times, you get the same answer, but I used u equals this, dv equals this. The reason being that I wanted the polynomial part to go away, and when you take derivatives, you eventually get to 0. So I did my derivatives, boom, 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 boom. Then I did the integrals, the antiderivatives. Crossy Road. I'll blame it on that. Okay, so that should be, and this should be this. Okay, and then that's going to change. Let's see, this thing, let's see, that'll be negative, that'll be positive. So now what I'm doing is after doing my antiderivatives, I think I just did derivatives. Such a rookie mistake. So if you do that, don't feel bad, because I did it too, and I'm 55 years old. I should know better. Anyway, So now I'm going to do these diagonals, and I'm going to multiply this times this. And then I'm going to multiply this times this times this. And then I have to remember that the integration by parts formula has a negative built in. So this first one will be positive, then you negate this, then you do a double negative for this one, which makes it positive, and then this one will be negative. I could even put those here, positive, whoops, how about this? Positive, negative, and then let's see if we can keep track. So it'll be this positive, this will be negative, but the double negative makes that a positive. Then this one will be a positive times a negative, which will make that a negative. Thank you for noticing that so that I can correct it in front of everybody. And then I'll upload the amended version of the answers in just a minute. And then this one will be negative. That one's correct. So I think I lost a few, at least, let's see, if this is worth 10 points, how many points do I lose? 9? Oh, I'm just kidding. I would never take off 9 points for such an error. I'd probably just take off 1, maybe even less, 1, right? We want to be generous. So there we go. So remember, you don't have to use this if you don't want to. And the one on the actual test, let me look at it. Where's the actual test? It's right here. Okay, so the one on the actual test, in the interest of full disclosure, there is one on the actual test that you could either do using 2 integration by parts or a table that looks like this, but it'll be a little bit shorter. You'll hit 0 a little bit quicker. So just so you know, you could just do integration by parts twice and you'd be fine. Nolan, what do you think?
For the table, how do you know if the
Oh, okay. So what you're doing here, or what I'm doing, is on this side, here, I guess I have to, oh, are you talking about the blue thing?
Yeah, how do you figure that out?
Oh, you just alternate. Start with plus, and you go plus, minus, because, and the reason is that when you do integration by parts, you get uv minus the integral of v du. But then you're going to do integration by parts again, and you'll get uv minus the integral of v du. But you have to think in terms of the fact that you have that uv minus for the first integration by parts, and then times uv minus, so double negative. So that's why it starts off positive, then it's negative, positive, negative. Okay, anything else? But when in doubt, I mean, on the test, you don't have to use the table. You could just do integration by parts twice, and you'd be okay. It's not that hard to do it twice. So it's up to you. The table is quicker. You'll be able to get a good seat for Tavares-Taylor. If you do it the other way with just 2 integration by parts, you'll have to sit in the back, and you might miss the first song, which might be okay. I don't know. Just depends on how you feel about the singing. So, all right, what else do we need to look at from this test? Let me go back to the blank version so that you aren't fearful. Nothing. You might change your mind in just a minute. Let me tell you what's on the actual test. So first of all, let me show you the actual test just to prove that it is not going to be hard. So here is the actual test. Come on, buddy. Get over there. There you go. Okay, so you can see clearly that what you have here is the very first question is integrate using your normal methods. Someone's got to, they need to get their truck fixed apparently. But so that's normal methods, just basic. Can you integrate x squared? I'm sure you can. Can you integrate this? Which I won't tell you what it is, but you can probably guess because it might be right there on my mug. And then this one, this is basic substitution, So the second one, basic substitution. Third one, integration by parts. That's the one that you're all scared about. Then you have, look, I've got all the trig integrals, or no, the trig functions, whatever, it's the trig stuff. Identities, that's what they're called, the ones that we used. And then you've got some basics. I tried to keep it simple. Like I said, I tried to keep the numbers small. And then I've got some basic trig substitution. Now, here's the deal, though, with the trig substitution, is because they are so basic, I had to specify here. Here, I'll just show you right here. Give me a sec. I'll come right back to this so you can enjoy it. But look, so compute each of the following using trigonometric substitution. This was such a pain. It took forever. And so what I did on the actual test is I did something like this. Instead of this, I had something like this, x times the square root of 16 minus x squared. And I said you're going to use x equals 4 sine of theta. Now, believe me, when you change it's not the 9. The 9 isn't the problem here. The problem is this x cubed. That's the problem. Anyway, when you change from x cubed to just x, the problem just works itself out. It's almost like you're just going to go along for the ride and watch it do its thing. Make the substitution, some things, combine, and you're like, wow, it's so easy. So anyway, but here's the problem with what I just did. In fact, I got to be honest, that might actually be the test question, or one of them. Anyway, the problem with what I just did is that it is so easy that you probably are looking at that thinking, why don't I just use regular U substitution? Yeah, you're right. If I had to do this, I would never use trig substitution for this. I would use U substitution. U equals this, du equals 2x dx. It's easy. But I need to test you on the trig substitution. So I made it easy, but I also specified in the instructions, use trig substitution. So use trigs, just humor me and use trig substitution. Come on, you can do it. But anyway, that's just so you know, that's the sort of thing that you're going to see for the trig substitution stuff. It's going to be easy trig substitution. In fact, let me see. Just a minute. I need my glasses. I can't see this stuff. Oh yes, clearly that's going to be that's so easy. I can do it in my head. Okay, I can't. I'm just pretending. But anyway, it should be pretty straightforward. Then I have separated the partial fractions thing into 3 parts. So I have something that's not on the practice test, I don't think, and that's the long division. You remember that? Okay. Anyway, there's a long division problem here. It's pretty easy. Then you have 2 partial fractions where you just have to do the partial fractions but not the integral. And I tried my best to make them work out nicely. I mean, they're partial fractions, so they're not going to be great. And then the last one, for the partial fraction section, I actually have it either almost completely done, like I've got it separated, or it's trivial. What you have to do, it's going to be super easy to separate it into partial fractions. So you have those partial fractions, joyous tidings. And then, what is this, 3? Apparently I have 3 improper integrals. You can almost see what they are there. And those, you just humor me and put a limit of some sort in there. Let me see, do I have a limit on the versions? Do I have a version on the improper integrals? I do have improper integrals. Let me see what I did. Hold on a sec. So on the practice test, oh, look at that. Oh yeah, we're going to loop back around in just a sec, I know, because I think I've given away too much, haven't I? But notice that at the very least, humor me and put this somewhere, put a limit, the notation, put it somewhere in your answer. That way I'll say, okay, at least you're thinking about limits in some form or another. So throw a limit in there so that I can feel good about myself, and then just do it however you want to do it, and you'll be in good shape. So apparently I've shown you too much, because now you know that what is not, oh, there is a quotient. I never did it. I didn't do that for the practice test. Okay, so on the revised, apparently, I think what happened was I got to this point and I was like, that's such a pain. And then I was just like, let's go on. And I did that. I never even saw this. Okay, so apparently I have more work to do. I will do that quotient and remainder. Oh, why is there a dx there? I don't know. Let's cross that out. That's completely unnecessary. All right. Okay, so I'll do the long division, show you how that's done. But one thing, where is it? There was something that I skipped over. Oh, this one. clearly, since I just went over what's on the actual test, this is not on the actual test, sadly. Oh well. It was fun though. It's good practice. If you did it, then good job. It's not that hard, is it? It's fundamental theorem of calculus. I think the rest is on. That's the only one. That's the only one that's not on that and the Simpson's rule. So I need to do this. So I will have to do this, but I'm happy to hear your pleas for help. Anything else? Yes, sir. What about number 6? Is it? Let me see. Have we never done number? Oh, interesting. Yeah, apparently that's not on the test either. But we did sort of do this, didn't we? Oh, I know what happened. Do we need to loop around after break? Yeah, I know what happened. It's right before the last test. We started talking about average values. Do you remember the fulcrum and the seesaw pictures? We were getting into the average value in moments, and what happened to them? They disappeared. Okay, we'll have to do average value, but it's not on the test though. So thank you for reminding me. We'll have to do some average values before we get into sequences and series. So anything else? So thank you. Number 6, apparently I can just here. Where's my little, there it is. So I'll just do this there. That way when you look at the, or if someone else, if you're looking, not on the test. How about this? Not on test. Not. Anything else that we need to delete from this test? Here, I'll do the same thing down here. No, not on test. So other cries for help? Okay, so look at this. We're done early, and Tavares Taylor isn't even preaching today. So here's what your job is between now and Friday. You get the day off tomorrow, but I'll be in. Set yourself up. If you did poorly on the first exam, please do see me tomorrow. I want to make sure you do better on this test. So try this practice exam. Come see me tomorrow, and you can make appointments. You can just pop in. I'll be here all day tomorrow. And come early on Friday. Try not to stay late on Friday. Yeah, but come early. You can come as early as 7:30, and I'll be ready for you. So I think that's it. Stick around if you want to